attention to a very powerful feature of CDAS from the raster menu, the math band item. This is only enabled when you have data open, and it's important to note that the math band operations can only be applied to those raster bands within a single file. If I had a second file open here, I could not combine a band from one of the files with a band from another file in a math band operation. We'll learn elsewhere how to combine bands from different files into a single file so that such a thing could be done. I'm going to cover this this math band capability in a couple or few tutorial videos, just so I don't try to plod through it all at once. And this first one, we're really just going to look at the user interface. Okay, so assuming, regardless of displaying any data, I have some data that I'm working with that gives me some bands to work with. I select the menu item and I'm given this user interface window. Now it defaults to a new band name that it's going to create as a result. You can give it a much more meaningful name, perhaps something like SST difference. Might be more meaningful than that. You can fill in a description. You can give the output variable units. For example, perhaps I intend it to be degrees C. This is really just filling in metadata for the output file. If you were creating a spectral wavelength calculation, here you might give a meaningful wavelength and set your units to nanometers or microns or whatever is appropriate. I don't usually fool with these. It's going to save text of the expression in the metadata of the output file, and that's fine. Now this bottom area here is where the expression can be typed, and as you get proficient at the math band capability, you might just type it in yourself. However, that can be prone to typographical errors, and so there is a editor for this expression that's very helpful. Okay, so when you click that, you get this second window in the user interface of the math band operation. Going through these elements on the left is a list of all of the bands and masks available for operation in your current file. Now you can uncheck, for example, the masks and just see the bands, okay, and narrow it down. Or, if you wanted to find a mask very quickly, you could remove the bands. So those are just conveniences to get you around the long list of data sources more quickly. In the middle here, you have shortcuts essentially to standard operations of addition, subtraction, and so on. You have a parenthesis shortcut so that you can build this expression but give precedence to certain terms in it by wrapping them in parentheses to be applied before the next binary operator or whatever in the expression. Okay, so these @ signs, if I click on one of these, for example, I get @ minus @. Well, these are just placeholders that I'm going to fill in with data sources from this list over here. And if I position the cursor just after one of them and click one of these data sources, it does the substitution for me. And that enables me to avoid typographical errors. It's taking the name that it sees in the file and replaces it in there. Now, then I could, just for example, I might want to see what is the difference between the calculated SST and the reference SST. So there's an expression that would derive that. And it's important to notice this text down here, okay, no errors. That means you've at least got a valid syntactic expression. It doesn't necessarily mean that you've got an expression that's going to do what you want it to do, mathematically or meaningfully, but it tells you that the expression can be used. If I were to introduce something like that, an equals sign, it means nothing. Minus equals is not in this expression. We're building up basically an expression. You can think of it in programming terms as the right-hand side of an assignment or equals statement. So it's going to flag that there's something wrong here, and until that goes green and says, okay, no errors, you need to work on the expression. Now, the other kinds of things you can introduce into this expression includes a set of predefined constant symbols. So there are, you can use the term pi as a constant expression, and when it does the evaluation, it will actually use an accurate, numerical representation of pi to the computer's capabilities. There's not a number that can be useful for filling in data and so on that you want to reject. It's got expressions for the latitude and the longitude. Now this expression is going to be evaluated for every pixel in the raster of the constituent bands. So it may be useful to use latitude and longitude in the expression for each pixel. And then there are just other simple ones. There's no problem just banging in a numeric quantity in this expression editor. These are just shortcuts for convenience in the constants. The operators reveals a series of expression operators. The common ones we have shortcut above, plus, minus, times, and divide are all there. But there are several that are basically logical operators. If something in the left-hand side of the expression or the right-hand side of the expression is true, then the output is true. Okay. So notice I can just click and type and delete and edit in that window. Some of these, there's an if then else, and we may see how that is applied in a future tutorial on this. You've got a logical, a bitwise OR and a logical OR. These are computer expressions. You can test for, comparative operators. At the bottom, you can do a logical NOT or an arithmetic NOT, which is a bitwise flip. So you've got a wealth of operators to choose from there. You've got some built-in functions you can apply to an expression. Now notice all these expressions have that little @ sign. Well, that @ sign doesn't represent a single term. It could represent a complete expression of itself. So I could wrap this entire expression here if I wanted, and one thing you can do is select and click abs, and so it wraps the selected terms in the absolute value function. So that allows you again to continue to edit the expression however you wish. Perhaps I don't really want an absolute value. I want to know what is the positive or negative difference between these two. Okay. Below here is a series of little tools to help manipulate the expression. If I hover over this, when I see the tooltip, it lets me select all. So if, I could click that and then I could choose the function to wrap that in. So these are just shortcut functions. I could use the trash can to, of course, clear the entire expression. I could undo with this one. And then it actually, as you use the editor through multiple sessions in CDAS, it's actually storing various expressions you've used. So you may be able to scroll back or scroll forward through a history of expressions and see ones you've used before and recall them and simply use them again. So that really is the simple user interface to this. Once I click OK here, it simply substitutes the edited expression that I created in that editor into this blank where a valid expression needs to land. And it's when I click OK that I will create a new band. Click OK. And here's a new band called SST difference. I had enabled to open it, and there it goes. So I won't stop here for this first tutorial because I just want to focus on the user interface. You can review this single video for anything that might have blown by too fast, but hopefully that was clear enough to get you started using the Math Band tool. Next, we'll look at actually doing some math and working with it.